Hi everyone, I'm Fariba Kenshan and today I will be presenting Exploratory Graphics XGx, an open source tool developed at Novartis for promoting purposeful exploration of PK/PD data. As a pharmacometricians, we come into this industry from many different backgrounds. For example, we are engineers, mathematicians, statisticians, pharmacologists, and so on. And we may see things from different perspectives or use different approaches to analyze our data. And sometimes we jump into complicated modeling before properly exploring our data. But what we have in common is we are driven to use data to answer the relevant questions. Each phase of drug development has its own specific questions to be answered. For example, in first-in-human studies, we may be trying to characterize PK, safety, and explore efficacy. In phase 2A or proof-of-concept studies, we may be trying to characterize these things in a relevant patient population and detect efficacy in this specific population. In phase 2B, we often trying to characterize dose exposure response relationship to help the clinical team to select a relevant and appropriate dose and regimen. And similar for phase 3, pediatrics, post-marketing, and so on. So how does we approach to answer these questions as a pharmacometrician? What type of models or analysis we use to establish exposure response analysis? Today, I want to focus on something very fundamental as a pharmacometrician that we do as a first step before doing any modeling, and that is data exploration. In the next few slides, I would like to go over and show you and introduce you to XGx and our website. We created Exploratory Graphics website and you can access our tool at opensource.niber.com/xgx. Our objectives are providing a structured approach for exploration of PK/PD data, providing a teaching tool with R to improve data exploration, improving efficiency and code readability for exploratory analysis using plotting function, improving quality of exploratory PK/PD graphics for better communication with the clinical team. And our key message for you is to do not just look at your data, but look at it in a more structured way. Here is a screenshot of our own main homepage of the website. This website is open source, R-based, and available at opensource.niber.com/xgx, or you can directly access our website and the contents in our GitHub page. The XGx website is organized based on the general flow of PK/PD exploration, starting with data checking, PK, PD, and then PK/PD data exploration at specific pages. Within PD and PK/PD page, we provided example based on the different PD data types, including continuous, binary, count, ordinal, time to event, and we also have a specific page for oncology endpoints. To encourage our user to have a structured and question-based approach in their PK/PD data exploration, each page of website contains key steps for exploring the data, as well as the example graphs and key questions to ask yourself to go along with each step. In the data exploration process, exploratory graphs are provided as well as the R code to generate these graphics. The website itself is generated completely based on the R Markdown documents, which are openly available on GitHub or in our website, and can be downloaded either from our website by clicking in the top of each page or from our GitHub page. As I mentioned, we are encouraging users to approach their data with relevant questions. In the next few slides, I am going to show you some of these questions and examples for PK, PD, and PK/PD data exploration. When we are exploring our PK data, we might ask this question: how many compartments we see during our data exploration process? Do we see exponential decline or we see bi-exponential decline? So that would tell us what type of compartmental, one compartment or two compartments model we should use. Do we see any nonlinear clearance in our PK profile? For example, the upper right graph displays nonlinear clearance, and you can say that the elimination phase are not parallel for each dose group. We can also establish the dose proportionality with relevant questions. Or do we see any sort of dose over or under proportionality? For example, in the bottom graphs, the dose normalized AUC and Cmax looks pretty flat with respect to the dose. So we can say that there is a dose proportionality, for example, for these two plots in the bottom. For PD, we want to see that if there is any relationship between the PD markers and dose. Does the response appear to plateau at higher doses? What is the pattern of response over time? Is there a steady state reached already in the PD markers? And for PK/PD data exploration, we might be asking ourselves if there is any positive or negative relationship between exposure and response. Is there delay between increasing in exposure and changes in the response? We also develop xGxR, which is an R package to improve our code efficiency and readability. The website makes use of this xGxR package, which we develop to improve the efficiency and readability of the codes. For example, in the figure below, you can see that it's the concentration versus time mean with a 95% confidence interval for each dose groups. In the middle box, you can see that there is an R code in ggplot to generate this plot without using xGxR package. And then on the right, there is an R code that uses xGxR package to generate the same plot. And you can see that with using the xGxR function, all those lines in the middle box from ggplot can be done in a one line of xGxR with the xGxR functions. In this slide and the next two slides, I am showing the list of the plotting functions which are available in our xGxR package. We have functions to set up your theme. We have functions to generate tables to provide a summary of your data and summarizing your covariate information. We have specific functions to generate confidence interval and percentile intervals. We have scaling functions that makes nicely spaced grid lines for plotting your axis in log scale. And we also have specific functions for saving and annotating. For example, if you want to have you're working with a non-validated data set and in your communication you want to have a flag like draft in your as a watermark to your figures, you can use annotate status. Or if you want to add the metadata to bottom of your figure, specifying the directory of your outputs, the time, the date of generation of those plots, which we usually need them in our submission processes, you can use annotate file name function. In addition to the XGX website, R Markdown documents, and xGxR package, we also have created the exploratory graphics cheat sheet. Our cheat sheet is a single page, front and back, reference sheet summarizing the key information from the XGX website. It contains the key steps, key questions, and graphs to go along with each step of data exploration. Also, some technical consideration and commonly used xGxR package functions are available in this cheat sheet. This cheat sheet is also available openly and can download it from our XGX website in the Resources tab, or you also can find it in our GitHub page. Now I'm going to briefly show how to apply XGX either website directly or R&D templates to your dataset. So the first thing you want to do is just go to our website by typing in your browser opensource.nibber.com/xgx. There are two ways that you can access the R codes and generate graphs. You can, first of all, select the specific page that you want to go. For example, in this demo, I'm going to click on the continuous PKPD data exploration. And there are two ways to get the R codes and make graphs. So you can either directly download the R Markdown document and use them as a templates. For example, in this example, in the left-hand side, I downloaded a document, and in the right, you can modify this document based on your own need. And for example, you can change the title, you can add your name as an author, you might want to label your figure, for example, if it's a draft, or you want to remove the draft, and specify the directory that you're planning to save your outputs. And this can be used as a metadata printed using the xGxR function to be printed below your figures. The other way to have the R codes and graphics is just directly from the website. In the website, click on the show the codes. Either you can show all codes or just click on the codes button here. And then the codes are going to be displayed, and just directly copy and paste the R code in your R working environment. And again, similar to the R Markdown, either you want to keep the draft or changing the directory, it's going to follow the same steps. One of the important things that you want to change in the either templates or if you're directly copy and pasting from our website is your data set, and making sure the name of the data set you have is matching the name of the variables we are using in the template. So what we are using at the data specification, our PKPD data specification, is the generic and general data specification that it's common across the industry. But if you're working with a specific data set with a different data specification column names, you want to match these names with your own data set. So at each page and each template we have in the website, we have also the PKPD data specification, just briefly telling what are the variables that been used in our RMD files and templates. And at the end, again, either you're using the RMD templates or copy and pasting from our website, you can just run the codes. and using the xGxR function, for example, for generating this concentration over time for mean with 95% confidence interval for each dose group, we are using the xGxR function stat.ci. We are using the scale y log 10 to nicely space the grid lines for y-axis in log scale. And also in this plot, we use the annotate status for having this watermark draft in our figure. I would like to conclude my talk with just summarizing that we develop an open source resource to encourage our pharmacometricians and users to have a structured and question-based approach in exploring their PK/PD datasets. So you can access the XGX website through opensource.nibur.com/xgx or our GitHub page. We have a cheat sheet available in our resources tab, and we also have xGxR package freely available in our GitHub page and also available in CRAN. So we always welcome your feedback, and so if you have any suggestions or if you're having any issues using either our tool XGX or our plotting functions XGxR, please submit your issue. We will be notified as a core team members of XGX, and we will get back to you. So your turn. If you want to use the XGX, we just put the very short instruction. So pick the page as an example in the website that you want to apply to your data set. Download the RMD from our website or GitHub. Save the RMD file and your data set in a location where you want to work, and modify the RMD based on your data sets, variables, and all the modification that you need to do based on your job. And then run the different graphics and look at the cheat sheet and look at their guiding principle with the relevant questions and some basic information about each of the plots and graphics. So with that, I would like to just very briefly acknowledge all the core team members of XGX, extended team members, contributors, and also Novartis leadership for supporting this initiative. So with that, I will stop here. Thank you for your attention, and I will happy to take your questions. Thank you.